recording this.
Okay, so all yours.
Okay, great. Well, thanks. So yeah, today I'm going to be talking about Azure Synapse Analytics. I'm going to be going through mostly an overview of it, but just talking about its various components, a little bit of the history, and just how we got to where we are with it today and how it's culminated in what is, I'd say, one of Microsoft's flagship products within Azure. And then also I'll be sharing along the way just a few little tips and tricks and observations that I've had just with my experience using it. So yeah, but as mentioned, it is a pretty key product to be used particularly with as it relates to data architecture and data engineering within Azure. So let's see. Okay, so just to go over a little bit, and again, anyone who's used Synapse Analytics is probably familiar with a lot of this, but there are multiple different components that make up the Synapse Analytics. So the central piece where you'll be interacting with it most is going to be Synapse Studio. So that's the integrated development environment where you can do all of your coding, create your artifacts, and just build everything that you need just all in one spot. Then you have a storage component of it. And so there's going to be, by default, when you create your Synapse workspace, you're going to have a data lake that you specify, and that's going to be Azure Storage Gen 2. And then also you have the option of creating dedicated SQL pools. And so this will be storage of data in a relational database. You also have a compute component of your Synapse workspace. So you have serverless SQL pools. Those you get a serverless SQL pool by default when you create a new Synapse instance. And I'll go into a little bit more about what that is. But then you also have the option of creating one or more Spark pools. Just to have Apache Spark running and be able to run data operations that way. And then again, you have the dedicated SQL pools. And so that serves as storage, but also it has the compute component as well. So, the full SQL Server database engine.
So just a quick question, the serverless SQL pool doesn't have any storage?
There's no storage in that, no.
Okay.
So I'll touch on that a little bit more in a later slide, but
okay.
But yeah, it's really just compute.
Gotcha.
And then you have the orchestration component, so creating your pipelines and data flows to be able to move data, do all of your ETL work or ELT work for the extract, transform, and load. Or the pattern that we see a little bit more often now is the extract, load, and transform to get your data into your final data warehouse. And then also another key component is that it has Git integration. So you can integrate it either with, I believe you can do GitHub, but then also it has integration with Azure DevOps Git. So going back in time a little bit to talk about where some of the components started. One of the resources or services that Microsoft had in Azure was Azure SQL Data Warehouse. And so this was just a standalone database. You would provision it in a similar manner as spinning up an Azure SQL database. You have your own virtual or a logical SQL server associated with the database. But behind the scenes, it had a very different architecture. So it utilizes massively parallel processing. It divides its processing and database storage across 60 distributions. I'll talk a little bit more about the distributions here in a moment. And then for the most part, the SQL data warehouse supports most of the T-SQL functionality. But there were several pieces that were missing for a long time. Microsoft is continuing to develop it and try and bring the features, to parity with SQL Server, like on-prem SQL Server and SQL DB. But originally, it lacked some syntax that was part of standard Transact SQL. And I think that was largely due to the difficulty in implementing it across these 60 distributions. So some examples of those were, for instance, you couldn't have identity columns in a table. And then the merge statement for a long time also wasn't supported. Another feature that wasn't supported, and I think it still is not supported, is writing like inserts and updates where you have multiple joins in the from clause and referencing a table alias to do your update operation on a specific table in the from clause. You have to specify that table that you're updating up front and then do your joins later on in the query. So a little bit of a workaround. You have to kind of write your code a little bit differently. Another thing to note about the Azure SQL Data Warehouse was, and still is that is more expensive than Azure SQL Database. But it also has a feature where you can pause the compute and save that expense when you're not using it. So over time, the SQL DW has evolved. So in 2019, toward the end of the year, it was rebranded as Synapse Analytics, but it was still effectively the same thing. It was just a standalone database with this distributed processing. And then in May 2020 is about when when Microsoft started shifting and making more of this the Synapse as we know it today, that collects a lot of the different functionalities and features. And so that entered public preview in May, and then by the end of the year, went into general availability. And so SQL Data Warehouse now is not really anywhere to be seen except in some older documentation. And it's now referred to as a dedicated SQL pool within your Synapse workspace. And the workspace then, with the general availability at the end of last year, introduced now the full Synapse Studio experience that you can see, for anyone who's worked with it. So now with the dedicated SQL pool, I mentioned I was going to come back to this and talk a little bit about the distributions. So this was a feature back when it was SQL Data Warehouse, and still is the way it is for the dedicated SQL pool. But all of your tables within the dedicated SQL pool are going to be distributed. And so there are 60 distributions within every SQL pool. And this distributed nature really is the key to optimizing your queries when using the SQL pool. So really the way it works, and you can kind of see this in the diagram here on the right-hand side, is that for every table, each row is going to be assigned to one of the distributions. So you can think of it as 60 separate databases that are running in the background, and they're all running in parallel. And so when you define any table, you have to choose the distribution function that you want to apply for having your data spread across these 60 distributions. So the one that's shown here in the diagram is a hash distribution. So you have a deterministic hash function that will say this record is going to go to this distribution, and then this next record is going to go to a different distribution, that sort of thing. And so with that hash function, based on the column that you're passing into that function, the same value that gets passed in is going to result in that record always landing in the same distribution within your SQL pool. Another option is to use round robin when you don't necessarily have a specific way that you want your records distributed across these 60 databases behind the scenes. So round robin will just randomly try to evenly distribute your records across the distributions. And then the last option is the replicate, which means that you're going to have an exact copy of your full table in each of those distributions. And so the reason you might want to do that is because when you're doing join operations, for instance, you need to make sure that the records with your join keys are going to be in the same distribution for your separate tables. And so sometimes that won't be the case, so it'll require some shuffling of data across those distributions. And if you have replicate turned on for a table, then you don't have to have that shuffle. Your table is going to be there in all of those distributions. So it'll be readily available to be able to make those joins. So typically you would use that for your smaller tables. If you have a star schema in your database, then smaller dimension tables, for instance, might use that replicate function to be duplicated across all the distributions. And then just the final note about that, as I've mentioned, there's always going to be 60 distributions, but depending on how large and how much you've scaled your the compute of your SQL pool, that'll determine how many different compute nodes you have. So the smallest size, for instance, you would just have a single compute node, so you have all 60 of your distributions on a single node. But then as you scale up, then you'll get more nodes. So you can have 10 nodes that'll have 6 distributions per node. And then eventually, if you get large enough, then you'll have 60 different nodes that have just one distribution per node. And then there's more information about this link that I've provided. So moving on to the next topic, talking a little bit about external tables. This is a feature that was introduced several years ago in on-prem SQL Server and also in Azure SQL DB. And what this allows you to do is to define they're almost like virtual tables within your SQL Server database. But these tables point to data sources that live outside of the database. So you can read data from these external data sources, but operate on them and query them using the familiar T-SQL syntax as if it was data that lives within the database itself. For Azure SQL Data Warehouse, for instance, and SQL pools now, these external tables can query data that's stored in files. So in blob storage or in Hadoop or in elsewhere in the Azure Data Lake Store. There are some additional capabilities for on-prem SQL Server and Azure SQL DB, where you can also create external tables that will point to other databases like Oracle and Teradata. But yeah, really, these external tables, as I mentioned, just allow you to define what is essentially a virtual table based on these the external data source and file format.
Tyler,
yes.
Is it related to Polybase?
It is, yes. These are often used interchangeably. So Polybase, typically I've seen that more in the context of the full featured functionality that you get from on-prem SQL Server and Azure SQL DB, where you can point to these other relational databases. Whereas typically the more limited scope that just points to files in storage, I've typically only seen that referred to as just external tables. But for the most part, I would say that yes, Polybase and external tables are pretty much the same thing. And then yeah, I have some more information in the link below here. And then here, just to give you a little example of some of the code to implement external tables. There are several pieces that you need to set up beforehand. Like for instance, you need to create your external data source where you're pointing to the actual location where the data is going to reside. And then you also have to define some of the attributes of the file format. So if it's a, telling your database whether it's a Parquet or just delimited flat file. If it's a delimited text, what is that delimiter? And then some information about different formats, like the date format here. And then once you've defined the data source and the file format, then you can use those to then define your external table where you specify the schema, and then you can start querying it from there. So building upon the external tables, that's where Serverless SQL Pool comes in. So as we touched on earlier, Serverless SQL Pools do not actually store data. So there is no storage within these serverless pools. They purely just reference data that lives elsewhere. So like in the various file storage. So let's see. So okay, yeah. So the serverless SQL pool, by default, there's always going to be one created with every Synapse instance that gets created. You really can't change that. It's always going to be created, and it'll always be there. And then since it doesn't actually store data, all it really contains is any metadata and object definitions. So you can create your external tables, external data sources, the file formats. You can create views, you can create functions, and I believe you can even create stored procedures. So all of these different objects can reside in a serverless pool, just not the data itself. And so this is where you would use, or one example of where you could use those external tables and define them just as in the shown in the previous slide. And then be able to run your queries and do some data analysis on data that resides in your files. One other thing you can do with the serverless pools that I've found handy is that you can define views, and views have a functionality that goes even beyond the external tables in that it provides some visibility to the file metadata. So for instance, you can read the file names and the paths of those files. So I've had some clients that I've worked with where they have data that's actually part of the file name itself. So like a client ID, for instance, might be part of the file name and not actually part of the data within that file. And so in order to get that data point, I need to actually read the file name and parse it. And then I can include that then as a column within my view. So that functionality can be pretty handy. So moving on to another component, Microsoft has implemented Spark pools. So this is Apache Spark instance that runs within the Synapse workspace. So you can create and run notebooks within Synapse. And it has support for several common languages. So of course, you've got Scala and Python. It also does have support for C#, and you can also use Spark SQL. One of the limitations that people often do ask about is support for R, and it does not yet have that, though I believe it is on the roadmap to implement at some point in the future. And then one piece that it also supports that is an attempt to give it feature parity with Databricks is support for Delta Lake. And I think just recently they have added support for Delta Lake version 1.0. So for anyone who has used Delta Lake, I guess that's some food for thought there.
Tyler,
Yes.
I just want to add the difference between Delta Lake and Data Lake. Delta data.
True. Yeah. Did you have a comment about that, or you want me to talk about the difference?
No, I just gotta say that Delta Lake supports transactions. That's the main thing. It has transaction log, and yeah, that's it.
Right. So yeah, so Delta Lake, yeah, since it does have that transaction log, you can revert to a particular point in time to see what your data looked like, and get certain time snapshots of your data, versus a data lake, which is simply just a storage for your unstructured data. So that brings me to data lake storage. So also by default, whenever you create a Synapse Analytics workspace, you need to specify a data lake that's going to be linked to it. So it'll always have a default data lake. And so if you have a data lake that you've created separately, just on its own, you can link to an existing data lake. Or if you don't have one created yet, you can specify a name and a container at the time that you're spinning up your Synapse workspace, and it'll just create a new Azure storage instance at that point in time. So just a note about data lake storage. Back in Gen 1, data lake storage was separate from Azure storage. And as of Gen 2 of the Azure storage accounts, they're essentially merged together. So there is no separate data lake storage now. Data lake storage is just a particular implementation of an Azure storage account. The one thing, really, there's just one setting that needs to be toggled when you're creating your storage account to make it a data lake. Is in the advanced tab, there's going to be a toggle switch to specify that you want to enable hierarchical namespaces. So if you have the data lake storage just created on the fly when you're building your Synapse Analytics workspace, it'll automatically toggle that setting for you and enable the hierarchical namespaces. If you're just creating a storage account on your own, just a standalone storage account, by default, the hierarchical namespaces is not enabled. So you need to make sure that you go and toggle that. And it's one of those things where you're locked in when you create it. So so you need to think ahead. You're not able to switch it back and forth after your Azure storage has been created. But anyway, let's see. So the data lake, yeah, it uses hierarchical namespaces. And then the other thing to know about data lake is that Microsoft defines that purely as the blob storage. So it's specifically a blob storage. with hierarchical namespaces enabled. So in your storage account, you also have other storage types like file system. And you can still create linked services within Synapse to be able to communicate with files that reside in the file system. But for data lake, as that's defined, that's purely just the blob storage. And the hierarchical namespaces, that essentially just means that Azure has an awareness of the folder structures and the subfolders and the way they're set up. So for instance, with Parquet files, you may have your data partitioned at the folder level, where you'll have, if you're partitioning by date, you might have a year folder and then month folders inside that and day folders inside that. So the hierarchical namespaces provides the intelligence to understand those folder hierarchies. The other thing about the use of data lake within Synapse is that when you specify it, that means that Synapse is going to create a linked service to the data lake with a default name that's going to be just whatever your Synapse workspace name is, and then dash workspace default storage. So I've found in my implementations that this is not user-friendly. That name can't be edited at all. It's just a fixed name. And so when you're trying to, if you're using a linked service that references your data lake storage, when you try and deploy to other environments using CI/CD, it just doesn't work very well with this, because you'll have different names for every separate Synapse workspace that you deploy to. So personally, I never use that default storage, or at least the linked service that gets created. I always create a separate linked service with a more neutral, non-environment specific name that can be reused across environments, so that I can use that CI/CD deployment to go from dev to QA to production. And I know I'm running out of time here, so I'll try and breeze through the rest of these. Another piece is the data orchestration. So going back in time a little bit, if we think about when Azure first really started getting going, they had their data factory Gen 1, and this allowed for some very rudimentary ETL. So there really wasn't a GUI for building your orchestration pipelines. It was all just in code and just in JSON code. And they just had some basic different components. So you were able to move data, specifying a source and sink. And here's just some sample code for how that was specified. And then you had some basic functionality to transform data. So you could call stored procedures inside of a database. HD Insight, which was Microsoft's implementation of Hadoop. And I think it does still exist, but it's not really in use much anymore. But you could call different activities within HD Insight, and you could also execute pipelines in ML Studio Classic, so the Gen 1 version of the machine learning. And there's information about V1 if you're just interested in that from a historical perspective. But then it got much nicer when Microsoft introduced Data Factory Gen 2. So now it has its own graphical interface, and it's all web-based. And it still generates the same JSON code behind the scenes, but for building your pipelines, it's just much easier. And just as you can see in this screenshot, there's a lot more functionality now. So the toolbox that you have in Gen 2, it introduced things like conditionals and iterations. You could do loops. You have these web calls for being able to use APIs. You can do lookups to database and get data sets back that you can then use. And so, yeah, just a much broader array of tools that you can use. And so the Data Factory Gen 2 then became the basis for the orchestration within Synapse. So the pipeline functionality that's in Synapse is really largely compatible with that of Data Factory Gen 2. There are a few limitations. It doesn't have support for integration runtime sharing. So integration runtime really is it's a piece of software that you would run to allow communication between a data source that is external to Azure and the Synapse workspace or the data factory that lives within Azure. So for instance, if you're trying to connect to an on-prem database, you would install an integration runtime. And Data Factory has the concept of integration runtime sharing, where you can have multiple different Data Factory instances that utilize the same VM and the same instance of that integration runtime. So you don't have to install it on multiple different machines, but you're unable to do that within Synapse. Likewise, the Synapse pipelines can't execute SSIS packages, and there's no support for Power Query. And a lot of these differences are outlined in the link that I've provided. And then the last thing, just kind of looking forward. So that's pretty much an overview of everything that currently exists within Synapse. One thing that has appeared within the last month or so is the idea of scope pools, but there's no documentation out online regarding that at all. So just what I've been able to piece together and some of my experience is that within Microsoft, they have an internal big data engine for processing data lake files, and they call it Cosmos. And it's kind of confusing because their internal Cosmos has nothing to do with Cosmos DB that you may have seen within Azure. This is a completely different product. And so there's a language that they use for running jobs in Cosmos, and their language is called Scope. And it's really just the language. It's somewhat of a hybrid between SQL and C#. So for your querying, you're able to use a lot of the clauses that you may be familiar with, select, from, join, where, and so on. But for transformations of fields within your query, you would use C# functions. So if you need to change data types, if you're doing string parsing, a lot of different things like that, it's all C# functions, and you wouldn't use the same functions that you use, for instance, within T-SQL. And then several years back, Microsoft did make a public-facing variant of Cosmos in Azure. And this public-facing version, the Cosmos engine, they called it Data Lake Analytics. And it only works with Data Lake Storage Gen 1. And then the language scope, they branded it as uSQL for the public use. Those have largely disappeared just because it did only have support for Gen 1 Data Lake storage. And now that people are moving to Gen 2 storage, it's not supported anymore. But now these scope pools have appeared in Synapse. Though I've heard that it's a private preview, and so it indicates that it may not have been intended to be toggled on. But we may see more of this in the future, so stay tuned for that. And unfortunately, I'm about out of time, so I don't know if there are any questions or comments.
Perfect. Thank you.
Yeah, you're welcome.
Yeah. So please make a video and maybe upload it to the folder on the Google Drive.
Okay, I will do that.
Thanks, Tyler. Yeah. This was a great overview.
Oh, thank you.
Thank you, Tyler.
Yeah, you're welcome.
Yeah, thank you.
Yeah, that was amazing. Thank you, Tyler.
Thanks.
Thank you.